Hi, in today's demo, we'll see how the external forecasting capability of SAP IBP can be leveraged by integrating it with our in-house forecasting tool, 4kast.ai, built on SAP BTP to deliver fluid, intelligent, and adaptive forecasts. Let's get started. SAP IBP already offers a strong suite of statistical and machine learning models for forecasting. However, some organizations look to go a step further by leveraging additional AI and deep learning techniques tailored to their business context. That's where external forecasting comes in. It allows us to extend IBP's capability by connecting it with our in-house forecasting engine, 4kast.ai, built on SAP BTP, which supports advanced models like Gaussian process regression, LSTM, VAR, and many more, while keeping IBP as the core planning platform. Now let's start with the configuration in IBP. Here we have a forecast model created using the external forecast type. In the configuration, we define the key figures used for historical demand input and forecast input, in this case, which is actual quantity adjusted and the statistical forecast quantity. And next, we also define the parameters that determine which algorithm will run on the PTP side. In this case, the algorithm name, here Gaussian process, and also the respective parameters to configure or make the model more efficient or run more efficient. Now, once the model is configured, IBP automatically prepares the data packet based on the selected planning area and key figures. This data, typically including product, location, customer, and demand history, is then sent through the integration layer to SAP BTP. Now, let's save this model currently. It's already saved. So let's move to SAP BTP, where our forecast.ai engine is hosted. So as you can see here, we have our BTP cockpit under which we have different sub-accounts. So let's move to the sub-accounts where we are hosting our innovations. All right. So under the sub-account, let's go to spaces where we have a dedicated development space for creating and hosting our applications. Yes. So once we're inside our development spaces, we can see dev here, where we will go and access our forecast.ai applications, or where we can see it. Yes. So if here we can see our in-house forecast.ai engine running as a deployed service. We first check the instance status to ensure that it's active and connected to the integration layer. So as you can see here, we have it as started. Now, this application is responsible for accepting input data from SAP IBP, running the selected forecasting algorithms, and returning the results in a format compatible with IBP key figures. Now, the engine logic has custom adjustments made to handle IBP's data input and output structures. This enables seamless two-way integration between SAP IBP and the forecast.ai engine hosted on BTP app while maintaining full compatibility with IBP's planning framework. Now, how this works, the communication between SAP IBP and the application hosted on SAP BTP is enabled through the SAP COM0830 communication scenario provided by IBP. This scenario allows us to integrate external forecasting algorithms directly within the Managed Forecast Models app. Once the forecast run is triggered in SAP IBP, a forecast request is sent to the BTP application via OData endpoints. The forecast is then executed on BTP and the resulting values are transmitted back to IBP for further analysis and visualizations. Now, let's trigger the forecast run directly from the SAP IBP. So here, since I've already selected the external forecasting model, which is Gaussian process, I just have to go ahead and save it and then move ahead to schedule the forecast run. So once I go to the application jobs where I can schedule the forecast run, I just have to configure certain parameters like the planning area, the version on the calculation level, and also select the model that we're going to run. Now, once this is all configured, let's go ahead and schedule the forecasting run. Yes. So when this forecasting run is triggered, or when I click on schedule, IBP sends the required data to BTP, where the forecast.ai engine runs the defined algorithm, in this case, Gaussian process, and then it returns the forecast values. Now let's go ahead to the Excel IBP add-on. And so here, what you're viewing right now is the planning area or the planning view that I've configured with a test data. So since I've already gone ahead and scheduled the forecasting run, let's go ahead and take a look at the status. ahead. So here we can see that it's still running. Let's give it a refresh. Still running. Let's wait a minute or so for it to complete running. Yes. So now the statistical forecast run has been completed and the result is sent back to IBP. Now let's go ahead and take a look at the business log. Now, as you can see here in the business log, the algorithm that we executed was Gaussian process, which was a custom forecast algorithm. And we can also see the MAPE and RMSE values that we have selected for each product location combination. And finally, we can see the overall result, which is finished successfully. So that means our model has run successfully. And to view the results, let's go back to our planning view. And let's just hit on refresh. Yes. So as you can see here, the forecast values are being populated on the statistical forecast quantity key figure, which we configured in the manage forecast models app before we ran the statistical forecast. You can take a look at the results here. So this basically summarizes the complete system flow starting from configuration in SAP IBP, data handoff to SAP BTP, model execution within our forecast.ai based forecasting engine, and results written back into IBP. This setup enables planners to run advanced AI-based forecasts while maintaining IBP as a central planning system. So this covers the entire demo. Thank you and have a good day.